Okay, we're going to work on rewriting expressions and rewriting functions using a technique called rationalizing. This technique can be used to rewrite a denominator of a fraction or a function, and I just wanted to point out we could also use this for numerators. It depends on the context. Our first two examples are going to be numerical. Okay. We're going to rewrite the fraction by rationalizing its denominator. For example, in example 1, we see that we have the ratio 1 over the square root of 3, and this quantity in the denominator is irrational, and so there might be a context where we want to rewrite it and not have a square root in the denominator. Well, we don't want to change the value of this fraction, so we're only allowed to multiply by 1. We're going to multiply by some number over itself, some number that's going to be convenient, and it turns out that multiplying by square root 3 over itself is the most convenient choice. Then we multiply across the top, 1 times square root of 3. We multiply across the bottom, square root of 3 times square root of 3. We multiply under the radical, so we need to think to ourselves square root of 9. We can simplify that square root because 9 is the perfect square, and our rationalized answer would be square root 3 over 3. Okay. Similar example, but a little bit more involved. We'd have the ratio -2 over the product 3 square root 5. We still want to multiply by 1 to get the radical out of the denominator. We're going to multiply by something over itself. It turns out that the most efficient choice, or the simplest choice, is to choose radical 5 over itself. It's not the only choice. Now across the top, -2 is not under the radical, 5 is under the radical. There's nothing we can do to simplify except just to write those two factors together, -2 times square root of 5. In the denominator, 3 is outside the radical, so we record the 3, and under the radical we get 5 times 5, or 25. And upon simplification, since 25 is a perfect square, square root of 25 is 5, and we'll get 3 times 5, or 15. And it would be appropriate just to write down 15, but I thought I would show an intermediate step. We might look to see if 2 and 15 have common factors, but they don't. So this would be our simplified answer. Okay. So there's two examples where we look for a factor that has a square root in the denominator, and we use that to rename our fractions by multiplication. Okay. We're going to expand that technique a little bit. Example 3. If I can find it and pull it over here. Here it is. This time we're going to look at something a little bit more involved. We have the ratio 3 divided by the sum, square root of 2 plus 1. Okay. We still need to multiply by something over itself, but the convenient choice is not going to be just square root of 2. It turns out that we're going to choose the conjugate of the sum. To create the conjugate, we take the first term, we take the last term of this denominator, but we change the operation. Since it used to be sum, we change it to a difference, and to rename, we're going to multiply by the difference over itself. Okay. Now we need to use the distributive property across the top. We need to take 3 times square root 2 and 3 times -1. 3 times square root of 2 cannot be simplified, but 3 times -1 would just be -3. Okay. Now in the denominators, we have a binomial times a binomial. We can use a process that we've talked about before, FOIL, where we multiply the first products, the outside products, the inside products, and then the last products. So we'll get 4 terms. The first product is square root of 4. The outside product, negative square root 2. The inside product, positive square root of 2. And the last product, negative 1. Okay. Take a look at that and see how it simplifies. I don't think there's anything in the numerator that I want to simplify right now. But in the denominator, I see opposites that should add up to 0. So negative square root 2 plus square root of 2 is 0. That leaves me the square root of 4, which is 2, minus 1. And now I can write down my rationalized answer, which is just 3 square root 2 minus 3. Some people would factor out the 3. I'll let you take a look at those equivalent answers. Interesting. Our answer didn't even have a fraction in it anymore. Okay, example 4 is going to be similar to that one, so you'll get a chance to try that again. Okay, let me scoot that paper down. Again, the directions are to rewrite the fraction by rationalizing its denominator. And if we're given this product over this difference, we're going to want to multiply by something over itself. But that something will be the conjugate of the denominator. And the conjugate will be 1 plus square root 3. Okay, so we rewrite the problem. And we need to do some multiplication. Okay, again, up top we have a monomial times a binomial, and we distribute. We take the 5 square root 3 times 1 plus 5 square root of 3 times square root of 3. The 5 has to stay on the outside. 3 times 3 underneath will give us 9 under the radical. And we'll simplify that in a minute. We'll get 5 times 3 or 15 right here in just a minute. I'll let you look at that. Okay. In the denominator, as in the example before, we have a binomial times a binomial, so we need to use FOIL. What's the first product? 1 times 1. What's the outside product? Positive square root 3. What's the inside product? Negative square root 3. And the last product? Negative square root 9. Okay. And we're going to learn that things add up to 0 when we multiply a number times its conjugate. We're going to learn that those middle terms a lot of times are opposites and add up to 0. Okay, let's write down our simplified answer. 5 square root 3, I don't see anything that we can simplify there. But 5 times the square root of 9 is equivalent to 5 times 3, or 15. And the denominator? These opposites add up to 0. I'm left with 1 minus the square root of 9. And we recognize 9 as a perfect square. And 1 take away 3, negative 2. All right. So this is a perfectly good answer. If the directions were to rationalize the denominator, we no longer have a square root in the denominator. But we want to be able to recognize some equivalent answers. So someone else might have recognized a common factor of 5 in the numerator. So if I factor out a 5 from here and here, I'm left with this sum inside the parentheses. Okay. And this negative can be moved out front, just as long as we recognize this ratio overall is a negative quantity. Okay. So those were numerical examples. I have 2 function examples that we might like to look at. We're running about 10 minutes into the video, so it may be getting a little long, but let's see. Tell you what, I'll introduce this example, and then I will return to this example in a subsequent video. So the skills we were looking at there, rewriting fractions, can be generalized to rewriting functions. And in the next video, I'll look at example 5 here. where we have a square root in the numerator. Oh, and I see I've made a... So this will be a different example. Neat. Okay. It'll actually be an opportunity to rationalize the numerator. Okay, thank you for your attention.